Off. So we're going to start today by looking at the Pythagorean theorem and extending it. And I want to cover this. So we know that if we have a right triangle, then the square of the legs added together equals the square of the hypotenuse, or that c squared is a squared plus b squared. And usually we write it in the other order, so let's fix that. And what is c squared, or c? What does it represent if we're in a circle, any circle?
The radius?
That's right. Oh, yes. Thanks, Natasha. Go ahead and sign in, everybody. So if we have any circle at all, we can always, for any point on the circle, we can draw a triangle that has its base at the center that goes up to the point and straight down to the x-axis. And what do we know if this is in the unit circle?
That the radius is going to be 1.
Yes. So for the unit circle, the radius is 1. And what is this horizontal distance? On the triangle?
Oh, that'd be A, or
Or, yeah, in fact, let's call this point AB. And now, yes, this would be A. And the vertical distance
would be B.
Good. So now we have a squared plus b squared equals 1. So that's true for every single triangle you can draw inside the unit circle, as long as you start at the center and go up to the edge. So what we want to do is connect this Pythagorean theorem with what we know about trig. So if we're in the unit circle, what is true about the first coordinate? What did we say that was equal to?
What do you mean?
So every first coordinate all the way around the unit circle has some special property. Every single x coordinate is connected with the cosine. If theta is the angle, we call it a central angle. And what a central angle is an angle that begins on the positive x-axis and it goes on the terminal side of the angle. terminal side is the side that, let's use a different color. So say this is our angle. And I'm going to call it theta prime so it's not being confused with theta. Theta prime is a central angle because it begins at the positive x-axis and it goes far edge of that angle. And what we're going to do is draw triangles, like so. In this case, we would have one. Let's call this A prime, B prime. So this distance, horizontal distance, is A prime. This vertical distance is B prime. And we would talk about this angle, the small angle, the acute angle. And that's another. So acute is any angle less than pi over 2 or less than 90 degrees. So is theta prime an acute angle?
No.
That's correct. We talk about, and we're going to talk about this lots more, but I want to set the seeds. We're going to talk about reference angles. And these are acute angles that are connected with non-acute angles. So the reference angle for theta prime is, we're going to call it theta r prime, but it's just this distance from the terminal side of the triangle to the closest x-axis. All right, so we've got, oh, and so you said that cosine theta goes with the first coordinate. What goes with the second coordinate?
Sine theta?
Good. And that means that we have a new thing. So we already said that x squared plus y squared is 1. But now we've got, for x, we've got cosine theta. For y, we've got sine theta. And now we've got some important notation. With trig functions, we almost never put the exponent on the outside like that. And if we put the exponent, if we wrote it theta squared, this is the cosine of theta squared. So to make it clear that we are talking about squaring the cosine, we're going to write cosine theta squared as cosine squared theta. And we'll write the sine of theta squared and sine squared theta. And that's true for all the trig functions. So we've got cosine squared theta plus sine squared theta equals 1. And this is our first trigonometric Pythagorean identities. And it's the most important one. So let's see what happens if we start with cosine squared theta plus sine squared theta equals 1. And let's divide everything by cosine squared theta. What would that look like?
It would look like sine, well, 1 plus sine square over cos square beta, oh, beta, sorry.
And then
1 over cosine square beta.
beautiful. And we're just going to do one extra step. Cosine squared divided by cosine squared is
1.
1. I'm going to rewrite sine squared theta over cosine squared theta as sine theta over cosine theta squared. And that's an okay thing to do because we're looking at a fraction squared, not just a trig function squared. I want to do the same thing with the second fraction. We've got cosine theta squared, but this one wasn't squared. Have I changed it?
No, because it's the same either way.
Good, because 1 squared is 1. Okay, groovy. What is sine theta divided by cosine theta? Which of the trig identities?
Tangent.
That's right. So we have 1 plus tangent theta squared equals, and what about 1 over cosine theta? What's the reciprocal of cosine?
That'd be, wait, I have it written down somewhere, just a second.
Sure.
Secant, right?
That's right. Okay, beautiful. And now we're going to go back to the correct notation because we never, well, very rarely do we write tangent theta all squared. So we've got 1 plus tan squared theta equals secant squared theta. And that's how you would read it. Tangent squared, secant squared of theta, or whatever is in that angle. And let's do the same thing, but this time, let's see, we've got cosine squared theta plus sine squared theta equals 1. And let's divide by sine squared theta. So again, let's just write it down. We're going to divide each term by sine squared theta. And the reason that we think to do this is that one of these new fractions will be 1. The same with up here. One of the new fractions was 1, which makes it a Pythagorean identity. Something squared plus something squared is 1 is a Pythagorean identity. And now, how can I rewrite these three fractions?
Well, sine squared theta over sine squared theta would be 1.
Good.
And then 1 over sine squared theta is
Well, let's do it in two
cosecant.
steps.
Oh yeah.
Yes, you're absolutely right. And how can I rewrite cosine square theta over sine square theta if I'm
That'd be
making you painfully?
cosine theta over sine theta, and then that squared.
Beautiful. And now tell me what you were wanting to tell me before.
Cosine theta over sine theta is cotangent. So that'd be cotangent squared theta. And
Yeah,
then
and I'm putting painfully many steps. Yes, go ahead.
No, it's fine. And then 1 over sine would be cosecant and then squared.
And we're going to rewrite it the way Ben said it. We've got cotangent square theta plus 1 equals cosecant squared theta. And those three, and I've got them written down here. Those three identities are the trigonometric, Pythagorean identities. The one I want you to know after you've had Alzheimer's is cosine squared plus sine squared is 1. You can easily get to the other two by dividing by something, if you forget. But this one you really need to know. So if we're given one of the trig functions and we want to find the others, then we want to identify which quadrant that particular trig function lives in, draw a triangle in that quadrant using the right triangle definitions, use the Pythagorean theorem, so one of these, to find the missing side, and then use the right triangle definitions to go back to what you wanted. So let's do that. I'm trying something, I don't know if it's new, but different today. I've put all of the examples and the tray this is on the same page. So the first one that we want to look at, oh, before we do that, so yes, let's start with writing tangent theta in terms of secant theta. So if we want to write tangent in terms of secant, we want to use an identity that just has those two, and we just saw it. So we're going to start with 1 plus tangent square theta equals secant square theta. And I'm going to remember what that square means, because that's important. How can I solve this equation for tangent?
Subtract 1 from both sides.
Beautiful. So now we've got, moments por favor. Now we've got tangent square theta is equal to secant square theta minus 1.
You can take the square root, but don't forget the plus or minus.
Beautiful. So what gets to happen on the left-hand side?
We'll just be left with tangent theta.
Good. So tangent theta is plus or minus the square root of secant theta squared minus 1. And the plus or the minus will depend upon the quadrant that theta lives in. I want y'all to do this. Write cosine theta in terms of sine theta. And I'm going to shut up so that y'all can do that. And I want to hear you do it, please, por favor.
Hey guys, what's up?
Nothing much.
How's everybody morning's doing all right?
Yeah, I'm doing well.
It's good, that's good. So it's asking us Pythagorean theory and Pythagorean identities to write cosine types of sine, right?
Yeah.
So we're just trying to find out which one is which first. So let's see. If we know one of our formulas is cosine plus sine equals 1. That's one of those things that we can write down.
Mm-hmm.
We're trying to find what here? Right.
Wait, isn't it cosine squared theta plus sine squared theta equals 1? Or am I wrong?
No, yeah, that's correct.
Yeah, that should be it. Yeah. It's the squared. Everything should have a square. If there's no square, that's probably wrong. So yeah. Cosine squared, sine squared equals 1. If you wanted to find
Oh,
cosine
we're trying to solve for cosine or
for
solve for
cosine.
sine.
So yeah.
Okay, cosine.
Let's try to find cosine first. So you would subtract sine to the other side. So it'd be, you could say 1 minus sine squared theta, right? Plus cosine squared theta, right?
Yeah, so it'd be sine squared plus 1 equals cosine, or the other way around. So
It would be cosine theta equals square root everything, because you're trying to just find cosine.
well, yeah, that'd be the next step.
Yeah, but square root plus or minus square root of sine squared theta minus 1. And then if you want to do the same thing, just flip. If you want to, like, do the same thing, is to flip the cosine and sine. If you want to think about it that way.
Yeah.
Sine theta will equal plus or minus square root of cosine squared theta minus 1. Still, you'd still end up in the same.
Yeah, I think we found the
It's both. Yeah, both.
Oh.
We found both of them.
found cosine and sine. So
Yeah.
Hey, y'all, something came up. I'm just finishing with the student really quickly.
all right,
Sorry.
that's all good.
No problem.
I'm here. I just trying to fix this. Okay. Sorry about that.
You're okay.
Thanks. So yes, I heard y'all do lovely work. And now we're going to start something that we're going to continue almost all semester long. And that is figuring out where an angle is and drawing a triangle in the correct quadrant. So first of all, let's look at this notation. Theta is n, and we're going to use epsilon for n forever. In which quadrant? Gosh, if we had labels, that would sure help. Where do we start? Which side do we start?
Oh, the positive x side.
Good. So we've got 0 here. And what's up top? In radians.
Pi over 2.
Very good. And to the left?
Pi.
Beautiful. To the bottom?
3 pi over 2.
And full circle?
2 pi.
Beautiful. We're going to consider a quadrant as a starting place and almost going to an ending place. So we're starting for this one, we're starting at 3 pi over 2, and we're going almost to 2 pi, but not including 2 pi. If we wanted to indicate that we're using 2 pi as well, then we would have to say we're in quadrant 1. So the beginning of the quadrant is included, the end is not included by definition. So what quadrant is this indicating?
That'd be positive minus or quadrant 4.
Quadrant 4, that's right. Beautiful. This notation, all of these notations, this needs to be something that you feel pretty comfortable with. Alrighty. So we're going to do this question 2 ways. We want to find the cosine theta if we know the sine theta and we know where the sine theta lives. So the first way we're going to do this is using the Pythagorean identity. And which one connected sine and cosine?
What was that? Sorry.
Which Pythagorean identity connected sine and cosine? Y'all were just playing with it.
Tangent.
No, which one connects the sine and the cosine?
Solving for cosine or sine? Sorry.
So we're just going to write down, I just want cosine squared theta plus sine squared theta equals 1. And since we're given sine and we want cosine, I'm going to do very quickly what y'all just did. We've got sine squared theta equals 1 minus cosine squared theta. And what's the key step?
Square root with the plus or minus.
That's right. Beautiful. So we have sine theta is equal to plus or minus oh I'm sorry, I'm an idiot. We want to solve for cosine so that we can fill in the sine. So it's going to be the same though. So we've got cosine theta is plus or minus the square root of 1 minus sine squared theta. And now we can insert the value of sine that we have. So we know that sine theta is negative 7/25. That might help us to square that. What is a negative times a negative?
Positive.
Good. And 7 squared?
49.
And 25 squared? You can cheat.
625.
Beautiful. So I need to put this number under the square root. Ooh, that's kind of scary. Let's figure out this number and then take its square root. So now I want to find 1 minus sine squared theta, which is 1 minus 49/625. And how do I do that? How do I simplify the right-hand side there?
Turn 1 into 625/625.
Beautiful. Everything in math is beautiful. Okay, and now what?
Now we can just subtract 49 from 625.
Let's see. Oh, I love it when we get to borrow. So we have 1, 11, 15. 15 minus 9,
6,
11 minus 4,
7,
and we bring down the 5. So we get 576/625. I wonder if 576 is a perfect square. So you're allowed to cheat. Take the square root of 576.
$24.
Yeah. And we know that 625 is 25 squared. So now we've got a number that we can put under the square root, and it's not as frightening. We have that cosine theta is equal to plus or minus the square root. We just found that number to be 24/25 all squared. Are these the same? 24 squared over 25 squared, is that the same as 24/25 all squared?
Yes.
Okay, good. And why would it help us as far as ideas go? Why does it help to put everything squared if it's under a square root?
So we can just get rid of that one square.
Good. So now we have that the cosine of theta is positive or negative 24/25. But where are we? Which quadrant are we in?
Quadrant 4, which is positive negative.
That's right. So which one goes with cosine?
Cosine goes with x.
That's right. So we found that the cosine of theta would be 24/25. Now here's the other way. So let's see. We know that the sine of theta is negative 7/25, and that theta lives in quadrant 4. So we're going to draw a triangle in quadrant 4. And we're going to use theta, even though our actual, let's call this theta prime. Our actual theta starts at the positive x-axis and goes to the angle, goes to the hypotenuse of our triangle that we just drew. And let's see how this can help us. So we've got a triangle. And we know the sign. Let's see. What is the triangle definition for sine? Got a right triangle, and let's call it alpha here so that we don't confuse it. If I know that I have opposite, adjacent, and hypotenuse, what is the sine of alpha?
So we're trying to find sine.
Just using the sides of a right triangle. How would we
So
write?
Is it opposite over hypotenuse?
Yes, very good. So, okay. So I'm going to write this as opposite over hypotenuse. And we are always, always, always going to make the hypotenuse positive. So radius or hypotenuse are always positive. And the negative is an indicator of direction. So if sine is opposite over hypotenuse, how can I which side would I label as -7?
the opposite.
Good. And which side would I label as the hypotenuse? It's a silly thing to ask. Okay, so we've got 25, -7. Now we're going to use the Pythagorean theorem, just like we did before, to find the missing side. I'm going to call it A because it's the horizontal side. Okay, and we've got, how can I find A?
How can we find A?
Yeah,
Well, if we know that 7 squared plus a squared is 25,
good.
we can.
All right.
So first we would square -7, which would be 49.
And 25 squared, we just did it.
625.
All right. And then,
We have to take the square root of both sides.
well, let's solve for A squared first. Let's get A squared by itself.
Yeah, so subtract 49 for both sides.
Okay, and then we've got, we said that was 576.
And then the square root of both sides would be plus or minus 24.
And now it's kind of easier to see the sign SIGN cosine of A, because we've got a triangle that shows that it's going to be positive. Okay, so now we've got the three sides of a triangle. What did we want to find? What were we trying to find? Cosine?
Mhm.
Okay, so cosine, in terms of the sides of a right triangle, what is cosine?
Adjacent over hypotenuse.
Good. Okay, well, what is the adjacent? And what is the hypotenuse?
24 and 25.
So I want you to get super comfortable with both methods. But the key here is that we're starting to get tools to work with to find trig functions when the numbers are not, when the angle is not known. It doesn't matter what the angle is here. The numbers that are nice, like 3, 4, 5, what do I mean by nice? What do I mean by 3, 4, 5?
3 squared plus 4 squared equals 5 squared.
Yeah. Numbers that have this property, if they're integers with this property are called Pythagorean triples. So it would be really helpful if you made a place in your notes just to write down that you can refer back to write down all of the Pythagorean triples you come across. So we've got 3, 4, 5, and we've got 7, 24, 25. And it doesn't matter what the signs, S-I-G-N, signs of the two smaller numbers, because when you square it, you're going to get a positive. Okay, I want y'all to find the sine of theta if we know that the cosine of theta is negative 4/5. And what quadrant is theta in?
The first quadrant.
Almost. We're starting at starting.
The
Quadrant
second
2.
quadrant.
Yeah,
'cause
that's
it's
right.
negative, positive.
Okay, great. So I want y'all to draw a triangle in quadrant 2 and do this and use the Pythagorean identity. Cosine squared plus sine squared is 1. So both ways to find the sine if we know the cosine, and just know that these techniques are techniques we're going to use all semester long. So it's really useful information, and I'm going to pause. Somebody help to start the. Okay. Okay. For the you found sine of theta two ways. Sine of theta equals theta.
Teacher, the audio sounds kind of like
Yeah,
fuzzy.
your audio sound is glitchy.
me fix that. Hello.
Hello.
Yo.
Turn any better. It's still glitchy.
Yeah, it is still pretty glitchy.
Yeah, it's still
Yeah,
glitchy.
it's still glitchy.
Okay. Let's hit print 100. It's giving me lots of copies. Okay. So maybe if I close them. Hurry up. Around. Sorry, this is so slow.
It's okay.
Okay.
Okay, is it any better?
Yes.
Okay, good. So I think I had too many things open, and I had too much pressure on the RAM. Okay. So we've got, I don't remember where we are, but we've got it wherever we are. Oh, yes, I remember. So y'all did this question, given cosine, find sine, and it was in quadrant 2. And here is the actual theta involved. So it starts at the positive x-axis, and it goes to the hypotenuse of the triangle that we drew. But we are going to think of theta prime as just this inside angle, the angle between an x-axis, any x-axis, and the hypotenuse. And theta prime is the reference angle for theta. In other words, it's the smallest angle we can draw that starts at an x-axis and goes to the hypotenuse. We'll have a better definition for a reference angle probably next on Wednesday, but I want you to start thinking about these words so that they all fall into place. So now we know that the cosine of theta is -4/5. How would we label the sides of this right triangle? If we know that the cosine of theta is -4/5, And what is the right triangle definition for cosine?
It'd be the x coordinates.
So, but that's unit circle. What about right triangle?
Adjacent over hypotenuse.
Good. We're going to go back and forth, back and forth, back and forth all semester. So this is awesome. And can the hypotenuse be negative?
No.
No, that's right. And when we have a negative adjacent or any negative side, that has to do with direction and not a negative measure. So we think of this as 4 units in the negative x direction. So this -4 in the numerator gives me the adjacent, and the hypotenuse is 5. This is what kind of triangle? What are the numbers?
Three, four, five.
It's a 3, 4, 5. And am I going to have a +3 or a -3 in quadrant 2?
Positive.
Positive. Good. So this is so important to know. We're not thinking of this 4 as a -4. We're thinking of it as a 4 in the negative x direction. So I've got a 3, 4, 5 triangle. And now I know that the sine of theta is just what y'all said. So say it again.
Opposite over hypotenuse.
Okay, good. But also, unlike the Pythagorean identities, I now have all of the trig identities if I want them, because I've got the sides of a right triangle, all 3 sides. So the notes that I sent y'all today have, this is the part that we are caring about right now. Oh, sorry. Okay, let's see. Here we go. This is the part we care about. So using the sides of a right triangle, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, cotangent is adjacent over hypotenuse. If we're in the unit circle and pxy is a point on the unit circle, then sine is y, cosine is x, tangent is y over x, and then we have the reciprocals. And where we're going next is for a point P that isn't necessarily on the unit circle. But these definitions going back and forth, it's really important to have them. And I included a little sketch for all 3. All right, so let's do this next question 2 ways. Let's use a Pythagorean identity to find tangent if we know secant, and let's draw a triangle in the correct quadrant and label the sides using the right triangle definitions and find tangent that way. So what quadrant begins at pi and goes to 3 pi over 2?
The 3rd quadrant.
Good. And let's just remind me what the signs are in quadrant 3.
Negative, negative.
Beautiful. So we have secant square theta. What is the Pythagorean identity that connects tangent and secant?
Excuse me, can you ask that question one more time?
Yes. What is the Pythagorean identity that connects tangent and secant?
Believe is a tangent equals secant plus 1?
The tangent is on the plus one side.
Oh,
That's okay. The reason that I remember that is that we divided through by cosine to get to tangent, and cosine had to be on the left. We divided by cosine. Oh, that's how we got the 1, and that's how we got the secant. 1 over cosine is secant. So I always go back to cosine squared theta plus sine squared theta is 1, and just remember it that way. Okay, so how can I use this identity to find tangent if I know secant?
Substitute secant squared with what we know secant to be squared.
8, yeah. All right. What is the negative squared? It goes away. What is 17 squared?
Uh, 289.
Thank you. 8 squared.
64.
And we've got tangent square theta. Can I move the 1 also in this step? Do y'all mind?
Yeah.
Groovy? So we've got, I'm going to write 1 as what over what?
64 over 64.
Okie doke. And we're finding 289 minus 64. Oh, there's no borrowing. That's kind of boring. 225. So we get 225 over 64. And now what?
We take the square root of both sides.
And
Don't forget the plus or minus.
good. Makes me happy. So the tangent of theta is plus or minus. I remember that the square root of 64 is,
8.
who knows the square root of 225?
It's 15.
Good. So our third Pythagorean triple is 8, 15, 17. Those are going to save us so much headache. I can't even overstress it. Now, which quadrant were we in?
Third quadrant.
Good. In the third quadrant, is tangent positive or negative?
Positive.
That's right. So we found that the tangent of theta has to be 15 over 8. And now let's do the same thing with a triangle. And we're going to think of theta prime. Do you see that I'm going toward the closest x-axis to get to my reference angle, my angle that is less than 90 degrees?
Yeah.
So we were given secant theta is -17/8. In terms of the sides of a right triangle, what is secant theta?
Hypotenuse over adjacent.
Beautiful. And the negative has to go with which side? Hypotenuse or adjacent?
Adjacent.
Adjacent.
That's right. So we're going to think of the adjacent side as -8 and the hypotenuse as 17. Okay, let's see. Adjacent side. So this is -8. The hypotenuse is 17. And let's pretend we didn't just discover that this is a Pythagorean triple. All we would do to find B is
8 squared plus b squared is equal to 17 squared. Well, it'd
Beautiful.
be -8 squared technically, but same
well,
thing.
yeah. Good. And 8 squared is
64.
17 squared is 29.
Yeah, 2. Yeah, 289.
So we get that B squared is 225. And that means that B is plus or minus
15.
yes. So now I've got, why did I label it with the negative and not the positive? What are the signs? In other words, what are the signs in quadrant 3?
Negative, negative.
Yes. That means that both legs are going in the negative of their particular direction. 8 is going in the negative x direction. 15 is going in the negative y direction. But this is weird. We got that the tangent was positive, and I've got a negative and a negative. So what are in terms of the sides of a right triangle, what is tangent?
Opposite over adjacent.
Good. So we get -15 over -8. And what happens with the negatives?
Cancel each other out.
Yeah. So we get the same thing. And we're going through a lot of steps so that you see the connection. But the thing with drawing a triangle is that not only do we now know the tangent of theta, but we know any other trig function of theta if we want it, because we've got all 3 sides of a triangle. And all the trig functions have right triangle definitions. And that's why we started there. Okay. I do want y'all to do the try this. Or which one did we just do? Oh, yes, that's right. So I want y'all to do find the secant if you know tangent and you know the quadrant. And I want to hear y'all talk. I'll be here, but I'm gonna, go away. And you've got the triangle. Are you good? Excellent. Okay, let's see if I want to do. Okay, this is something else, and I want to do. Actually, I'm sorry about the wishy-washiness. Let's stop and restart, and take 3 minutes of break.
All right.
I'm gonna